What makes this different from what we did yesterday is that you've got to account for when you have variables in the top of a fraction. Okay, so in that way, they're thinking of it as that being the coefficient. If you look at example 1, you've got x squared over 2. That's the same thing as saying x squared times a half. Okay, so in any case, today I'm going to teach you how to most easily solve these. Okay, so if you have a situation like what you have with example 1, so it's x squared over 2 is equal to 2x over 15 plus 1 over 10. If you notice, I left a little bit of a space in front of each one, and there's a reason why I did that. Like yesterday's lesson, the easiest way to deal with these is to knock out the fractions. Not necessarily convert them all to the same thing and then add and subtract, but to simply clear the fractions. That's what it's called in the pre-algebra book. Clear the fractions. And the way you do that is by multiplying everything by the least common multiple, which happens to be the lowest common denominator. So this would be everything gets multiplied by a 30. Okay? So if you do that, you're going to cross cancel, and in the end, that eliminates that denominator. Okay, so in this position, I have 15x squared. Okay, the 15 and the 30 here cancel, becomes a 2. 4x is in this position here. Over here, the 10 and the 30 reduced by a factor of 10. Plus 3. Okay? There's the equation we're left with. Now, can we solve it? Definitely. Last chapter we learned how to solve situations like this. The method we were taught was to take everything to one side, equating it with 0, and then factoring to solve for 0. So you would end up, of course it's already factored for you, but you might have to hunt around to figure out the factors. So it's 3x plus 1 and 5x minus 3, right? Again, you could do this on your own. This isn't something you need practice at. It definitely takes time, but you can do it. 3x plus 1, 5x minus 3. You solve each piece for 0. So this is going to be x is a negative 1/3. You guys remember how to do that? Or on this side, x is a positive 3/5. Okay, so there's your solution set. If either one of those is possible to make this a true equation true. Okay, so you could write your answer like this, or I always like to just separate them so that it's clear what my answer is. Okay? It doesn't matter how difficult or how big they are, the solution or the procedure remains the same. Here's another one for you. This one's not in your books. You're going to have to copy it with me. X squared over 9 minus x over 6 minus a half. All of that equals 0. So, greatest common factor of 9, 6, and 2 is 18. I didn't leave my little spaces. So, 18 over 1. This one's going to be multiplied by 18 over 1. And this one by 18 over 1. Okay? Doing that will allow you to simplify by canceling out your denominators. 9 and 18 reduced by 9. So this position is 2x squared. 6 and 18 reduced by 6, giving you a negative 3x. And lastly, the 2 and the 18 reduced by 2 minus 9. All of that equals 0. Okay? After you hunt around and work to factor it, And again, this is going to be the time-consuming part, is finding the factor. 2x plus 3, x minus 3, negative 6, positive 3. Okay. Solve both pieces for 0, and you'll have your answer. 2x plus 3 is 0, so it looks like it's x is negative 3/2, if I did my arithmetic correctly. And on the other side, x minus 3 is 0, so x would be a positive 3, right? Your solution set is going to be a negative 3/2 and 3. Okay? So these are equations. All right? What happens if you have an inequality? Doesn't change anything. This isn't going to be any of that weird absolute value stuff. Don't think about that. This is very simple inequalities where a couple of old rules come into play, but not much. Let me go over one of these. I've got a couple examples to do like this. So x over 8 minus space x minus 2 over 3. I want to have room. Greater than or equal to space x plus 1, 6 minus 1. Okay, left my spaces so that I have room for my greatest common factor. 8, 3, and 6. Would you say 24? 24 over 1. Okay. By doing that, that's not a t, that's over 1. By doing that, we're able to eliminate those denominators. In the pre-algebra book, they call it clearing the fractions. Both of these are divisible by 8. So, in the first position, I have 3x. Both of these are divisible by 3. So now I have negative 8 x minus 2. I'll deal with that in a minute. Okay, because that became an 8. Greater than or equal to 4 times x plus 1. 4. I'll deal with that in a minute. I just want you to see where I'm at. Minus 24. Okay, nothing cancels there. You see that. All right? So we've got to distribute, and then we'll simplify. So I'm going to distribute my negative 8 here and here, which gives me 3x minus 8x plus 16. And I'm going to distribute my 4 here. 4x plus 4 minus 24. If I did all of my arithmetic right, we should all be on the same page. Combining like terms, looks like I have negative 5x plus 16 being greater than or equal to 4x minus 20. Okay. Move some stuff around depending upon where you want to move it. I'm going to move it this way. So I'm going to have 9x on my left. Since that's the case, I'm going to also transfer my constants to the right. Okay. Now, this is the rule that you need to remember from pre-algebra. When you divide by a negative number or multiply by a negative number in an inequality, it forces the symbol to flip. X becomes less than or equal to 4. Okay? That's the end of that. No other answer. Okay? We'll do another one just like it. Okay? This is another example too. This is not in your book, but it is in my book. X minus 14 over 4. And I really recommend leaving spaces in front if you can remember to. I always forget. Okay, I forgot that time. That's okay. Greatest common factor of 4, 12, and 1 is going to be 12. That's handy. 12 over 1. 12 over 1, and I'll just put the 12 over 1 behind it. Same feature, no big deal. Okay? You guys with me here? All right. Cancel by a factor of 4. And for sake of argument, let's go ahead and just distribute the 3 into the x and into the negative 14 to save ourselves this space that I left room for up there, okay? 3x minus 42, if I did my multiplication right, is greater than or equal to, cancel out my 12s, how nice, 5x.
I think Olivia Jackson and Lewis.
Minus 36.
Olivia and Lewis.
Okay? Move everything around, see what you get. Now, I believe in this case, we're not going to have to flip our signs because I'm not going to have a negative coefficient. So I have negative 6 is greater than or equal to 2x. And I hate talking it this way, so I always flop it over and I make it 2x is less than or equal to negative 6. Do you guys see how I still have the skinny side pointing? Positive coefficient means when you divide it, it doesn't flip the sign. Negative 3. Okay? Today's exercise of 1 through 16 all means